Welcome to the episode 2 of AI.cast, Smart Operations Edition, Minimize Risks. I am Anthony Tusanski, CEO of Codento, your AI.cast host, and a seasonal cover band drummer. Up to 20% of annual sales revenue is spent on preventing poor quality, pricing quality, or mitigating the consequences of internal and external failures. That is 1/5 of pure waste. This may be the case in your organization too, and now it is time to do something about it. In this episode, we'll hear how Codento's and Google's customers have harnessed the power of AI and large language models to better serve their customers, improve the quality of their operations, and save on costs. We will hear real-world examples from our customer Fastems and from Google on how to improve employee and customer experience and save costs with computer vision, preventive quality control, maintenance, and industrial safety. So let's dive into some of the grooviest ways of operational leaders to use the new AI technologies. Hi Vesa-Pekka, welcome to AI.cast. Can you tell a little bit about Okmetic and your business you are in?
Hello Anthony, and thanks for having me here today. And yes, Okmetic is a silicon wafer manufacturer located here in Vantaa, Finland. And silicon wafers are a critical part of the global semiconductor and sensor supply chain. So it's the basic raw material where everything really starts from. And Okmetic is operating in the global market in this, and our silicon is involved in many of the devices that are part of our everyday lives. So you can basically find Okmetic silicon anywhere within the devices that you are using daily.
Excellent. You have been Okmetic's Chief Quality Officer since 2020. In the press release about your nomination, Okmetic stated that your position was founded to meet the customer needs better and faster and to increase operational efficiency. What is the role of quality in Okmetic's business?
Quality is a very critical part of the business, and this semiconductor supply chains are one of the most demanding supply chains in terms of the quality requirement. So the devices made out of the silicon are extremely small and very sensitive to many kinds of factors that are kind of beyond the recognition of the human eye, so in the very like microscopic or even nano level. And because of that, the quality expectation from the customers in this field is really zero defects in regard to any issues with the product quality or delivery performance of the product.
Now you have been in the role over 3 years. How do you see the role of technologies such as artificial intelligence and machine learning to changing the quality environment?
I think it's an enabling factor for digging deeper into the factors that are impacting the quality. And it's also a productivity factor regarding the engineering work in this field and also in the other fields. Nowadays, the value of data is increasing in basically 2 dimensions. So one of them is that getting from this kind of larger group lot level data into individual wafer traceable data. It's one factor, and it's enabling to track also the process related factors into and connect those into the individual wafer measurement results and get more precise or kind of higher resolution information about the factors that are impacting the quality. And then the other dimension is moving from certain points within the wafers on some kind of factors that are describing the entire wafer into 2-dimensional map data of individual wafers, and this is another factor, and especially the map data is something where artificial intelligence gives very good opportunities in using things like machine learning or pattern recognition for identifying interesting factors out of huge amounts of data in an efficient way. So of course it's basically possible to compare 2 wafer maps or 10 wafer maps manually by a human being, but when thinking of very large amount of data, then the AI and machine learning have a good potential and possibilities of improving the productivity of this kind of engineering work very efficiently.
So it sounds like that the quality leaders and AI's role will in the future go in hand. Thanks, Vesa-Pekka, for joining.
Thank you.
Google has productized visual inspection AI for manufacturing customers. Google has developed computer vision algorithms, and we retrained this for manufacturing customers in the visual inspection AI solution. It can detect certain manufacturing defects like dents, scratches, and others. It can also be used in assembly line setup to detect conformance of the assembly, so that every product includes correct parts, correct installation or assembly sequence, no additional or misaligned parts or components, etc. The differentiation of our visual inspection AI is that because the algorithm is pre-trained by Google, customers can take it into use with very small sample label dataset, meaning that as little as 100 photos labeled by individuals can be utilized and trained the model for the customer's specific use case. Typically, the competitive solutions require tens of times of more sample data and photos to be trained for their specific need. We have multiple reference customers using visual inspection AI. Foxconn, Kyocera, Renault, for example, have used it in production in large scale for many years. Google provides a list of supported devices like cameras and lightings, etc., that we can guarantee that visual inspection solution is easily deployable and the outcome and results are good for the customer. Our customers can easily try and test visual inspection AI with the help of our partner Codento. They have experience and access to the technology.
So now I will talk about predictive maintenance and how you can do that on Google Cloud. When it comes to predictive maintenance, the data requirements are such that you will want to have these recorded events of failure. Under what context and at what time did a machine actually fail? You want to have these failure events recorded, and let's assume that you now do. What we want to do next is that we want to create this kind of a health index for your machinery. And this health index should then of course measure the health of your machine, and we should be able to see the degradation of this health index over time towards this failure point. And once we have this for your historical data, we can now start modeling this for the current live data that is constantly coming in. We of course want to get as close to a failure event without actually going there, so that we can then schedule a maintenance event just before the machine would actually fail. So basically we want to model the remaining useful life of a machine, but we want to maximize the utilization that we can get out of that machine before a maintenance event. If you don't have this failure event data recorded anywhere, you probably have maintenance event data recorded somewhere. And then what we can do is we can now use this maintenance event data as a proxy for failure. This works quite well in the real world because people don't usually do maintenance events for fun. They are done for a reason. So the proxy actually works out quite well in this case. If you want to get started with this kind of a predictive maintenance case, you can contact us at Codento. We have experience in doing these kinds of remaining useful life modelings and predictive maintenance modelings. And we can even give you suggestions on what kind of data you might want to add to your database so that we can make this modeling exercise even better.
Google sees a lot of potential high priority use cases for generative AI technology and solutions in manufacturing industry. One of the most obvious LLM use case in the context of manufacturing is to use it to interpret vast amounts of telemetry and machine data to detect certain patterns, trends, anomalies, etc. This helps them to reduce unplanned downtime, to optimize operations, and maximize efficiencies in production. Manufacturing customers can also deploy large language models and generative AI for customer service automation. Large language models can also help manufacturing companies' field maintenance teams to be more efficient by providing them easy access through natural language to all kinds of product documentation, support manuals, maintenance instructions, etc. Do this in a simple and easy manner using natural language queries, even doing translations from one language to another, etc. And all of this provides a lot of efficiencies and optimization capabilities for the field service operations.
I'm Riikka Käsnänen. I work at Fastems as a technical product manager for our digital solutions. Fastems is a leading supplier of machine tool automation systems. Our mission is to help our customers get the most out of their machine tools and other devices. To get the most out of their automation systems, our customers need to also utilize the quiet hours, meaning that they need to run production also during nighttime. Normally our systems run in a closed network, which means that our customers have difficulty to see the status of the system outside of the factory premises and outside of business hours. And by providing IoT connectivity into the system, we have been now able to provide them a digital service platform, which gives them opportunity to see the system status whenever and wherever. So that means that they have visibility to the system in their pocket in the comfort of their homes. In addition to the real-time visibility to the system status, we are now able to also collect the data automatically from the systems to utilize in our own businesses. In the past, we have been collecting productivity data manually from the systems to provide our customers with system analysis reporting. The large language model is utilized for pre-processing the data into a human-readable format, which means that we can save time from our experts when they only need to proofread the content and add their insight into it. During the process of using a large language model, we have learned that we really need to focus on what kind of questions we give to the language model, because they don't really know the context, so we need to be really precise for what we ask. In the future, we are also planning to utilize the large language models into providing our customers chat. We can utilize the translation functionality of the chat for enabling our customers to ask questions and get answers in their own language. We also want to utilize the large language model into generating case-specific instructions for our customers based on their alarm data. We have also other thoughts about how we can utilize AI and machine learning in the future, and a couple of bigger themes there are the condition monitoring and preventive maintenance of our systems.
Customers who are using Google's enterprise generative AI products and tools don't need to worry about the security. The data is always customers' data. Customers own it, they control it. It will never be used to train with Google's own models. We recently made a very big announcement regarding our enterprise generative AI tools and products, and now we provide indemnification for our customers for using those products. If you are challenged on copyright grounds, we will assume responsibility for the potential legal risks involved.
Well, that was a massive amount of new insight. Hope you enjoyed it. It was interesting to hear how Fastems is using generative AI for customer service professionals to help them with accurate insight of a current problem at hand. The next episode of Codento AI.cast on the topic of smart operations is also soon here. The next time it is going to be about using transparent data and Google's powerful AI tools for manufacturing to effectively predict and lead your business. You can lean back and relax, as when you have subscribed to our AI.cast at Codento.com, we will notify you by email of the availability of our next episode. To get started with trying out the power of AI in your organization, book a free AI value workshop for smart operations at Codento.com. So see you soon, and thanks for watching.